Welcome, Algebra students, to Mr. Chow Time. We're still on Unit 1, Expressions and Equations, but now we're on Lesson 3, the properties of numbers. And if you're following along in the book, this is going to start on page 16. Okay. Vocabulary. Equivalent expressions. An expression that represents the same number. So, for example, if we had 3 plus 2 and 4 plus 1, these two expressions are equivalent. Great. Now we have a bunch of concepts. I'm going to read them all to you, but you could easily just read these all on your own as well. Reflexive property, any quantity is equal to itself. So if there's two numbers and they are the same, these are equivalent expressions basically, right? So for example, 4 plus 1, that equals 5. So these are quantities that are equal to itself. Symmetric property, if one property equals a second quantity, did I say property? If one quantity equals a second quantity, then the second quantity equals the first quantity. And this is pretty much summed up right here. I won't even write anything. A equals B, B equals A. This is the symmetric property. Transitive property, if one quantity equals a second quantity and the second quantity equals a third quantity, then the first quantity equals a third quantity. Again, this is illustrated perfectly here. If A equals B and B equals C, then A must equal C. Substitution property. A quantity may be substituted for its equal in any expression. So if you have A and that equals B, then you could substitute one for the other, right? So if n equals 11 and you know that, and you have this expression here, equation, 4n equals 4, 4n, I'm saying all kinds of crazy stuff here. You have this expression, 4n, then that's going to equal 4 times 11, because you can just substitute this 11 into this n. Next slide. Here we have some addition properties. The additive identity, you might remember from last year. That's if you add 0 to any number, it remains the same. The additive inverse means that if you add the opposite number on the number line, then you get 0. Multiplicative properties. The multiplicative identity, again, you should have learned this last year, and if you remember it from last year, then that's great. And that is that any number multiplied by 1 is still that number. Multiplicative property of 0, if you multiply any number by 0, then you get 0. Multiplicative inverse for any number a over b. So this is basically any rational number. Then that number, a over b, can be multiplied by its inverse, which is b over a. If you multiply it by its inverse, then you get 1. Any number, for example, 2/3, has an inverse, which means that you just switch the denominator and the numerator. So the inverse of 2 over 3 is 3 over 2. You multiply those two together and you get 1. Next slide. Here we have an example. Let's evaluate this expression here. 7 times 4 minus 3 minus 1 plus 5 times 1 over 5. And we're going to name each property that we use in each step. So I'm just going to write it again because I like to. I'm that kind of guy. Okay, so this is going to equal what? Well, the first thing we do is the inside the parentheses, right? 4 minus 3. And 4 minus 3, I'm just going to write this up here just to make it perfectly clear. 4 minus 3, that equals 1, right? So we can substitute 1 into this expression, which would mean we would put 1 right here. Minus 1 plus 5 times 1 over 5. So, what property did we use? We used the substitution property, because we've substituted 1 into this part of the equation. So, what can we do next? Well, now we have no more operations inside of groupings, so we go to the next thing in the order of operations, which is multiply and divide. We'll do it left to right. 7 times 1. Well, that just equals 7, right? We'll just bring everything else down. And how do we know that? How do we know that 7 times 1 is 7? Well, this is the multiplicative identity. Multiplicative identity. All right, what can we do now? Well, the next thing we have to do is 5 times 1 over 5. We don't have any other option because that's the next thing in the order of operations is still multiply. And so 5 times 1 over 5, what is that? Well, that's 1. That's 1, yes, it sure is. And how do we know that? Well, this is the multiplicative inverse. Well, I'm not going to write this whole thing again. Multiplicative inverse. Then we can just do 7 minus 1, which is going to be 6. How do we know that? Again, we have substitution. I'm just going to write sub. And then here again, 6 plus 1, that equals 7. How do we know that? Substitution. And there we have it. Now, you could have done all this work, obviously, without writing every single step. And you could have done it definitely without naming the properties. So why do we do that? Well, we have to eventually do this thing called proofs. And proofs require us to be able to explain the steps that we went through to prove that something is true. And so we're just getting practiced in on that skill. Our next concepts are the commutative and associative properties. You should remember these also from last year. Commutative has the word commute. Commute means to travel. So if we have a expression that only has addition or only has multiplication, or if we have a grouping that is only multiplication or addition, then we can move the numbers around. 4 plus 8 is the same thing as 8 plus 4. 7 times 11 is the same thing as 11 times 7. The numbers can travel around. They can commute, and that's okay. The associative property has this root word, associate. To associate means like who you hang out with. So like hang out partners. Who I hang out with, who I associate with are people who are nice and generous and friendly and honest. Those are who I associate with. Those are who I hang out with. So groupings are like hanging out, right? And if you're grouping only addition in an expression or only multiplication in an expression, then you can feel free to move those groupings around. So 2 times 6 times 9, where 2 and 6 are grouped, well, you can just group 6 and 9 instead. You can change who they hang out with. So let's look at our last example for the day. Mr. Chow is buying decorations for his first classroom. Congratulations to Mr. Chow for having his first classroom at KAS. So he buys an office chair for $4,500. He buys some blinking lights for $5,500. He buys a snack table, yum yum, for $43.50, and a desk organizer, a really fancy one that has like electronic organizers and I don't know, maybe some other high-tech stuff in it for $7,500. Find the total cost of these items. Well, that's going to be $4,500 plus $5,500 plus $43.50 plus $7,500. So, as you can see here, the hold on a second. I see what's so confusing now for me. I miswrote this. This is actually supposed to say 5550. So we'll just make this as 5. Okay, so it would be easier to add these two numbers together and these two numbers together, right? So we can just move them around. We can just write it like 4,500 plus 7,500, and we can even group these if we wanted to. Plus 5550 plus 4350, because these are easier numbers to add together. So this is 12,000, right? I hope so. And this is 9,900 plus 12,000. What is that? That's going to be a 009 21,900 NT. Balla. And that's it. Thanks. Have a good day.